Hey guys, Professor Roman again. So now we'll start with dispersion and understanding dispersion and absolute deviation and standard deviations and concepts such as that. Okay, so far we did mean, median, and mode, and we kind of covered those concepts in our earlier class. So mean gives you, you have a bunch of observations, and each value can be like high or low, and now think of this as like the price of a good, and this could be the type of good. This could be like rice and like bread and whatnot. Like pop. So when you're trying to get a basket of goods and you're trying to find out the average price of the product you're buying, of the bunch of products which you're buying, whatever it is you're trying to figure out, the mean kind of gives you the central tendency of the value, and so does the median. And mode also tells you what value occurs most frequently, and so on. But a lot of times there'll be wide variation in prices, right? Like so, even within rice alone, within types of rice, you have like basmati rice, you have long grain rice, and you have like jasmine, like sushi rice, and so on. So you get the idea. Like, but there's wild variations, and like long grain rice tends to be cheaper. You have brown rice, which is like a little more expensive. Jasmine rice is like, and sushi rice can be a little more expensive than the rest, and so on. So you get like wide variations in terms of what the average price is. And so not all things are the same, and sometimes you will be interested in seeing how different is each rice from each other. So there's another example in your textbook here. It gives you an idea of like there's two manufacturing plants. They manufacture LCDs, and so both of them have the hourly output as 50. They produce, think of it as like 50 TVs per hour. So that's the hourly output. This is the plant at Kanata near Ottawa, and the one at Waterloo. So, however, when you try and take the number of observations, 1, 2, 3, 4, 5, 6, 7, 8, 10, that's 9 observations here, and there's 9 observations here as well. Okay, so these 9 observations are all clustered around 50. So the average, just your X bar, is 50 monitors, 50 LCD monitors per hour. And the average for the Waterloo plant also is 50 monitors per hour. However, you could see like here, everything's going all right. If you're an operational manager, and if you want to try and see, are there any issues? Is manufacturing process flowing smoothly? You look at the Kanata plant and you look at the output per hour. You could kind of try and see, hey, output stays fairly close to 50. There's not much deviation. And but here, when it comes to Waterloo plant, some days it's like outputs are 50, some days it's 47 and 53, and on some random days, one it's as low as 40, and one day it's like as high as 60 or something. So you could kind of look at this dispersion and figure out, well, there's something wrong here, right? Like on some days, why is it so low productivity? Like, are you not scheduling the worker shift properly? Is there a manufacturing plant breakdown? And so on. So there's some kind of different problems, and you could try and investigate into what the problem is and try and figure out. Just by looking at this graph alone, you could kind of figure out that there's something wrong with the manufacturing and the process at Waterloo plant. Okay. So, and this is a wide distribution. If you could think about the Waterloo, and the Kanata plant is like a tight, narrow distribution. Like everything's like clustered toward near the mean, and here is a much bigger spread around the mean. So how do we measure this kind of wideness versus like narrowness is kind of known as what the dispersion or deviations, if you could call it. And this is an example, and like how do we kind of measure this, right? Like the most simplest way is the range. Take the maximum value minus the minimum value, and that's your range, right? This is one way to do it. But another way to do it is also to try and do some sort of like mean deviation, right? Like depending on the number of observations, the range might not give you the best idea. So for weather forecasts, the range is usually given, like your average high, your daily high, your daily low, what the range would be, and so on. So, but the range does not account for the number of observations, right? So try and think of another example where, let's say, the same plant. So like before, we used to have 9 observations. X bar was 50 monitors. Most was produced. Only the y-axis. So, and if you try and think about the observations, so before this was how the observations were, right? And now let's try and add more observations, right? Like if you have even more observations, and so on. So I'm just going to draw circles because it's easier, right? So you have a bunch of observations which are kind of clustered over here. And suddenly you have like, oh, on one random day something happened, and like, hey, you have an outlier over here, and then you have an outlier over here. And so if you try and take the range over here for this one, let's let this one be like 60, and let this one be the same as similar to your previous thing, 40, right? 40, but most of them are between like 47 and like 50. Most observations are. So on most days you get the best output, and like you get like one observation on your left corner, and then you get like one observation on your right corner. The range would be like 60 minus 40, which is 20. And like this is the Kanata plant. So yeah, this is the Kanata plant. And look at the Waterloo plant. And if you try and draw something similar, as far as 50, your observations are a little more diverse. Let's say the distribution looks a little more like this. No? And here, if you take the range as well, the range is 60 minus 40 is 20. Right? So the range is 20 in both plants, in both the Waterloo plant and the Kanata plant. But this doesn't tell you anything useful. But we clearly know, if you could see from the graph, from the data points observations, that the Kanata plant is much better in terms of, or much more reliable in terms of getting an output of 50 LCD monitors per hour, whereas the Waterloo plant is not very reliable and it has a lot more variation. So the range is not the best measure because of this reason. And so there's other measures, right? Like, but range is a good measure for certain kind of applications like weather. So now let's go to the next kind of measure of dispersion, which is the mean deviation. So mean deviation would try and take the x minus x bar. So you're trying to find out the absolute deviation. So the mean deviation is also known as the mean absolute deviation, or MAD. So sometimes you might come across this term. Instead of MD, you might MAD. And the mean deviation is x minus x bar divided by n. So right, so it's the summation of the individual observation, which is x, minus the average. And you're trying, what do these two brackets, the straight brackets, refer to? This means this, like, it's absolute, right? So even if the difference between these two over here is negative, you still take the positive value. That means it's the absolute only positive value. Okay, and you divide that by the total number of observations percent. Okay, so this does account for the total number of observations. So clearly you could say it might be better than the range in terms of providing what it is. And this is the mean absolute deviation. So these two square brackets indicate the absolute value. And let's try and there's an example of how to do this in your textbook, but I'll let you do that example by yourself. Let's try and go to an exercise problem. Let's try and do question number Well, 39, right? Like, or let's do 38. Seems to be a little bit shorter. Okay, so there's a sample of 8 companies in the aerospace industry, and all their results. Let's do 39 again. It's 10 randomly selected young adults. It seems to be a little more fun. The sushi and pizza rather than the aerospace industry, which is boring. So, a taste of the newly developed sushi pizza with tuna, rice, and kelp on a scale of 1 to 50, right? So 1 means they did not like the taste, and 50 means they really love the taste, right? And they asked this rating, and these were the 10 ratings. So let's try and enter them in our spreadsheet and try and calculate this. So this is going to be mean deviation or mean absolute deviation. So the observations are 34, 39. I'm going to look at my textbook so that I can enter this straight away. $34, 39, 40, 46, 33, 31, 34, 15, 45. So these are the 10 observations, and so what is, in order to try and calculate the mean absolute deviation, so what is the formula over here? Formula which we saw before was x minus x bar. So your first step in some sense is to try and calculate the arithmetic mean. So mean is just the average of these values. It's just 33.1. So for each observation, you need to try and create what you know as x minus x bar, right? So this could be thought of as x minus x bar. Okay, so that is point. So 34 minus 33.1, and these are your values. And in Excel, you could do it a lot simpler. So this will be your x minus x bar. And now it will be like absolute value. You need the absolute value of this. You could do an abs function in Excel, or just convert every value to positive if you do not know. Okay, so this is the absolute value. Okay, you see the negative 2.1 becomes 2.1, negative 19.1 becomes 19.1, and so on and so. And then you divide. Then you sum them all up in the numerator. This is going to be the sum. You could do all of this by hand in a nice piece of paper. I recommend doing it by hand first and then trying it on Excel. Do not just jump into Excel and just blindly follow what I'm doing. Try and get comfortable with solving these exercises by drawing tables and doing it by hand with your calculator. So 78.8 is the sum of everything, and then the mean deviation or mean absolute deviation is the sum divided by the number of observations. So in our case, it's 10. It's 7.88. That's our mean absolute deviation over here. Okay, 7.88, and so it tells you the average value, which is the average value. If you take a random observation at any point in time, it is 7.88 away from the mean, you know. So this indicates like a normal dispersion, right? So now this gives you a better idea of how to interpret the result. Like 7.88 is how often the person is away from the mean. So the mean here is 33.1. So with the mean and the mean absolute deviation, you could kind of get a better idea of the distribution, you know, especially that you know that the maximum value someone can get is 50 and the minimum value someone can get is 1. You know? So in this range, so there's still some people who do not like it because because some people absolutely hated this thing. So this is not the best number. And the company could try and figure out to improve its taste to maybe reduce the people who hate it. Or it could say, you know what, there's always going to be some people who hate sushi pizza, and try and focus on getting these average values better, however, and try and target these people and see what they did not like there. And do a second round of testing on them in terms of like trying improving the flavors or whatever the objective for the firm is, right? So these are some ways in which they could try and interpret the data in a better way. And that is mean absolute deviation. The next one is one of the more common one which is being used, is the variance and standard deviation. They're both roughly the same thing. Variance is just the square, and standard deviation is just the square root of the variance. Okay, so whatever you did over here in the previous mean absolute deviation, that involves one extra step. Okay, so we're going to try and compute the standard deviation for these exact observations instead of trying to go to a new problem. So now we're going to try and compute the variance and standard deviation. Okay, so let's try and understand what variance and standard deviation. So here, whenever you had negative values, you kind of took the absolute value of them and converted them to a positive value so that you could compute some sort of score. So remember, when we talked about what 7.88 is, it means if you pick any one observation out of these 10 or any one person in random and ask them to rate the score, chances are they'll be 7.88 away from the mean. It could be both in the positive or in the negative direction. But if they are 7.88 away from the mean is how you interpret this mean absolute deviation. When it comes to variance and standard deviation, instead of just taking the positive value, when it comes to variance, you square them. Right? Like you have your x minus x bar over here, and here you so this is known as the population variance, and so this means you're using the full population. So the population of the statistics class is all 33 students. If I do not want to ask all 33 students of you, a sample of those 33 students would be like 10 students or 15 students is a sample of the class. But if I'm looking at the whole class, it's all 33 students. That's my population. So the average grade or whatever, if you try and think about it, and if I try and find out the average grade, that is this mu over here. It's the arithmetic mean of the whole population, which in our case is the classroom. Or in this scenario, it's these 10 people who are surveyed for the sushi. So let's actually go for a different example. Let's try and figure out 6, 7, 8, 9, 10. Okay, so let's assume there are only 10 students in our class. And this is the whole set of population. So 10 students in class. And so this is what we have right now. And these are your grades out of 100. I'm randomly entering grades. Oh, that was... Okay, so if you try and take the average of the population, or this is known as mu. This is the mu over here. And so this will be $77. So the average grade is 77 out of 100. And so here you're trying to think about what is the difference. So the same concept, x minus x bar, whereas here it will be x minus mu because it's a population. This is going to be 60 minus, they're very similar, so x minus x bar and mu. I'll tell the difference later. So these are the differences. And here, instead of the mean absolute deviation where you took the positive value, here you're squaring these differences. X minus mu, whatever the difference between the observation and the average value, you're squaring the difference. Okay, so these are the squared values of the differences between the observation and the average. Now, once you square them, you sum them up and you divide by n. So the sum would be so the variance is going to be the sum divided by the total number of observations. The variance over here is 126. Okay, so what the variance does in some sense is the further the observation is away from the mean, by the act of the squaring, in some sense it punishes these observations more. If you could try and think about it, it says, well, you're much farther away from the mean. So when you're trying to think about, oh, it's a wide distribution, it kind of amplifies the more extreme observations in terms of how volatile your distribution is, or it kind of gives you a measure where these extreme observations in terms of deviations are amplified in terms of dispersion. Okay, so this is known as the population variance, and variance is used very, very commonly because people, like if you're trying to do any sort of quality control, people like certainty. You want to be more, everybody likes certainty, and humans on average do not like uncertainty, right? So if your average is 77, and even in this class, a lot of you would be okay if you're saying like, hey, you're more likely to get around 77, and the variation tends to be very little, then you're okay with that, you know. And whereas if there's a wide distribution where there's like the average is 77, but a lot of people get like in the 90s and a lot of people fail, and a lot of the students, even if you're an average student who usually do not fail, you'll be a lot more scared that you might fail in this class because you just hear about a lot of people failing in a particular class. And so that tells you the idea of distribution. But this 126.28, it's measured in some sort of like a square terms. It's hard to make what this number actually means. Okay, so in order to kind of make this a little more intuitive, whatever we squared over here, we're going to try and take the square root of it. Of this whole, not just whatever we squared. So the population variance is this formula, and whatever you find from the variance, if you try and do the whole square root of the whole concept, is the standard deviation. So this one over here, in order to find the standard deviation, you just take the square root of this value, and it gives you another value, which is 11.26. Okay? So this 11.26 can be interpreted in a very similar fashion as the mean absolute deviation, where if you're trying to think about it, hey, the average person in this class, if you just pick a random student, that person is around 11% higher or lower than the mean. All right, so 77 is the class average. So most of the classroom falls in the range, most of the class falls in the range of, to be more precise, 65% of the class, around 65% of the class falls in the range of 77 plus 11 or 77 minus 11. Okay. So in these ranges would be where most of the class falls. So here, most of the class would be between 88 and 66. So 65% of the class would be between 88 and 66. Okay, so that where do I get the 65% from? That's just a known fact. We'll talk about that later in the next video. But this is how you calculate the standard deviation, and it is just the square root of the variance, and this is how you compute it. And the standard deviation is a more preferred way, and it's the most commonly used method of dispersions, variance and standard deviation together, rather than mean absolute deviations or just ranges. In finance, at least in economics, standard deviations are used and variances are used very commonly as the preferred method of dispersion. And we will talk about more methods of dispersion or scales later on. But these are the four: range, mean absolute deviation, and variance and standard deviation together are your four major methods of measuring dispersion. I'll see you all in the next video.